Welcome to this new video. In this video, we are going to discuss about how to convert a Snowflake model to star model, or otherwise Snowflake schema to star schema. So here you can see this is a Snowflake schema and this is a star model, and how to convert this model to this model. So as a detailed Snowflake schema, dimension tables are normalized. If you are from SQL background, you know how good a table will be when it is normalized. A database, when it is normalized, it will be easy for the developer to get all the results, whatever they needed. But the problem for Power BI is that searching results in Power BI through Snowflake schema is very tough because it will take a long time because we are dealing with lots of data. So filtering a Snowflake schema will cost time. So it will be better to change the Snowflake schema to star schema. So Snowflake schema will use less space to store dimension tables but are more complex. So when you consider star schema, dimension tables are not normalized. So when you discuss about a star schema, it will be like you are putting in SQL, you are putting everything in a first normal form or something like that. It will be looking like that. It won't be purely normalized because we need everything to be like a star model. Star schema will only join the fact table with the dimension tables, leading to simpler, faster SQL queries. So this is kind of a Snowflake schema, Snowflake's model in Power BI, where you have a fact table, and with respect to the fact table, you have two dimension table, and in this two dimension table, one dimension table is connected with a star kind of another three dimension tables. So if we take the example here also, this dimension table is connected to another two dimension table, and the for this dimension it is connected to another dimension. So this is a pure normalized table, so it looks good in the picture, but in the real time it will take time. So this is a better way. So we have a small database and we have changed this to another just two dimension and one fact table. You can even create a dimension of for calendar. So this small example, we will be creating the star model from this Snowflake model, and we will be changing into this much this much dimension table. We will be changing into two dimension table along with the fact. So what is the process for all these things? So we have described here the process. We are going to deal with the left hand side. This much of dimension tables we are going to deal with, and you can see the first dimension table we have. Inside the first dimension, it is linked with another three tables. So we are going to we will be joining this table to this table. That means, okay, when you see it in a bigger picture, we'll be joining this mode table to this habitat table using merge query. And from this so this will be the first step. We will be joining this mode to this habitat table using merge query. And then next, so once you merge it, it will be looking like this. The mode we will be unloading the mode table, so it won't come into the picture. So all the mode values will be here. Mode environment name will be here. We will be taking out the mode ID because since we are so mode ID is needed to connect habitat with mode. Now you only connect habitat with mode table. We are directly entering the mode environment name to the habitat, so no need of mode ID. So the same way we will be joining this habitat table to the product ID. So once you merge this habitat table to the product table, this habitat ID will be taken it out from both the tables, and all these columns will be seen in this product table, and this habitat table we can remove. Same way we can use the species table. You can merge it with product table, and you can take out the family name, and instead of family ID you can take it out, and instead of that you can use the family name. So that is shown here also. So we have taken out the habitat table here, and we have enlarge the product table. And now the next step will be merging the species table to the product and taking out the species table. And this is for the right side, and right side means this much of tables we are going to deal with. Same way, first we will be taking this table and we will be merging with this table. This is a region table, and we will be merging it with town table. And then this town table will be merging with POS table, and we'll be taking out this town table. And finally, this POS type table will be merging with POS table. So finally, at the end of the thing, at the end of all the merging, we will be having only two dimension table and one fact. So we will see how this has been going on. So we have a data set, and this data set is having lots of around 9 tables we are having. And if you see the model, this is the same model which we have shown in the presentation. And this model is having one fact table, and here that fact table is joined with two-dimension table, and one side of the dimension table it is joined with another two three-dimension tables. Same way the product table is also joined with two three dimensions. So what we need to do is that we need to join all these things, and we have to have just these two tables, meaning all these columns we can merge it into these tables. Usually for practical purpose, when we will consider only the necessary columns. We will be merging to the dimension table and create a dimension table. But here, since we are doing it as a simple example, we are going to take all the columns from all the tables and we are going to create this dimension table. So for that, we can go to transform data. So in this transform data, the first thing what we need to do is that we need to take this mode table and we have to merge it with the habitat table. So we will select the mode table, or we can select the habitat table. We are going to use the left outer join. So we have selected the habitat table, and here in the home menu, go to the merge queries. We got the first table for the merge query. This is the left table, and that is a habitat table. And here we are having one environment ID, and we can take the mode table here. Mode table is also having the environment ID. So with these two IDs, it is being linked between habitat and mode, and we got 7 exact matches, and that is a left outer join, and we can select OK for merging. So we got the mode table here. In that mode table, we don't need the environment ID because environment ID is already here. So we can take the environment name, and since we got the values from the mode table, there is no need for using the environment ID because we already have the environment name. For the environment name only, we need to use the environment ID. Now we no need to have the mode table also, so you can just disable this load. For the warning, you can select it. Now if you apply and see, we will see we can no need to close and apply, just go to apply. So we have applied it, we will see so now we will see the model. In this model, you can see that mode table has been taken out. Instead of that, the mode environment name is being joined to the habitat. Now all these values we will join it to the product table. So for that, we can go to the product and go to the product table here, and there you can go to the merge queries, and mostly it will be habitat ID is there. So you can go to habitat table, select the habitat ID. Both the IDs are matching. We can use the join with respect to the product table. So we will be using the left outer join. We can select OK, and the habitat table has been merged in this product table. So we don't need the habitat ID. Remaining everything we are going to take. So when you end up production environment or the development environment, only the necessary things we will be taking. Now, since it is an example, we are going to take everything. And since we got all the details from habitat table, we don't need this habitat ID. We can just remove it. And at the same time, we can disable this habitat table also. And the data loss warning, of course, the data loss in that habitat table there will be a loss of data. But since we have merged it to this product table, all those details will be shown in this product. So for us, no problem. So once again, we will apply and see. So the habitat table is gone and all the details are being transferred to the product table. So yes, the habitat table is gone, and if you enlarge the product table, the details about the habitat and the mode table, everything is joined and the product table. Now the species also we can join to the product table. So go to the once again to the product table and merge queries. And here the species, there will be ID. There will be an ID connecting the species and product. That will be this family ID we will see. So we got the species and of course we got the family ID. So we are going to connect both. We got the species table in this product and we don't need the family ID. We just need the family name. And we are going to remove this family ID because we got all the family details to the product table. So now after this, we are going to disable the species table also, and we will apply and see. Now we will check the model. Of course, when you check the model, okay, we got a one side of star schema. That was a Snowflake schema that we have changed into one side of the star schema. This is that you can consider this as dimension table and the fact table. And now this portion also, if you do it the same way, you will get another dimension table. Together with that, we can consider this as a star schema. So now we are going to join this region table to the town table. So you can go to the town table, merge queries, and you can select the region table and region ID is common in both the table, and we can select OK. And the region table is merged to the town table, and no need of region ID. Region name is only we need it. We will remove the region ID also. And at the same time, we can disable the region table, and we can apply and see. When you apply and see, okay, the region table has been gone, and at the same time, the region name has been transferred to the town table. Now this time, town details, we will be transferring it to the POS table. So we can go to the query, we can go to the POS table, we can merge the query here, and there will be a town ID in POS table. At the same time, we will select the second table as town table and just select the town ID because two IDs will be matching. And of course, we got the details of town table in the POS table, and we don't need the town ID here. We just need the town name and the region name here. Similarly, the town ID here in this POS table, we can remove it and we can disable the town table. Now we can play and see. So now we got rid of town table also. Now all the details about the town and region has been transferred to the POS table. Now the POS type also we can merge it with this POS table so that we will get another side of the stars model. So it is the same POS and merge queries, and it will be sender type ID. POS type, if you take, both are having sender type ID, you can merge it with this ID and we can select OK. And of course, we got the sender type ID and sender type name. We can deselect the sender type ID because we don't need that. We got the name. And here also, no need of this sender type ID. We can remove it. And at the same time, we can disable this POS type because this details already we have in POS table. Now, if you apply and see, we have applied it. Now we got exactly two dimension table and one fact table. So star schema basically means that okay, one fact table will be the middle and the surrounding will be dimension tables. Now, of course, we don't have too much of dimension table. We have just two. One more dimension we can create, and that will be a calendar where we can join with this purchase date time. So for that, we can take the purchase, we can reference or duplicate this purchase table and referencing it, and we will be changing it to calendar. The name we can change it to calendar name, and here we will see here also one payment date is there. We need to change the data type to date, and here one null value is there. If you want, you can select and fill it. And now we need only this purchase date time. We will take the remove of the other columns and we will just remove the duplicates. So now we will close and apply. So we are in the model now. Now we have another table called calendar table. We can join this purchase date time to this purchase date time, and of course that also. So this is like a star schema where we have three different dimension tables and one fact table in the middle. So it will be better to filter out this whatever is necessary from the dimension table, and it will be easy and time consuming when you do all the filter operations using the fact table. You can do an example and go to the visualization option. We'll get the visualization and we will be selecting the price, and at the same time we can select the calendar option. We can select the year and month. So we have this option, and now we have two dimension table, and anything we can take. We can take the region name. We can create a slicer and we can create a region name. This will be, can take the region name, and if you select the region name, it will be with respect to the region name, the values will be changing, and it will be easy for the user to use because there will be no complications will be there. Just we are connecting to just another table. It's not from 5 tables we are going to get, just one table we are going to get the result. So this is how we will change a Snowflake model to star model. It is easy. You can try it out and explore it more. Have a nice day.